You ever wonder why an all-out sprint leaves you totally breathless in just a few seconds, but you could go for a jog for what feels like forever? Well, it's not just about trying hard. It's about the incredible science happening inside your body. The science of your energy engines. So let's dive in and figure out how your body fuels every single move you make.
Here's the game plan for this explainer. We're going to start with that big question, why sprints and jogs feel so different. Then, we'll get into the two main types of exercise, zoom right into the body's universal battery, introduce the three engines that keep that battery charged, and finally, see how they all work together like a perfectly timed relay race. All right, so let's start right there with that feeling. That night and day difference you feel in your muscles and in your lungs during a sprint versus a jog. Because understanding that feeling is the key to unlocking this whole topic.
Really think about it for a second. One is this just violent, explosive burst of power that you literally can't keep up. The other is a sustainable, rhythmic, almost comfortable effort. The difference between those two feelings? Well, it all comes down to how your body gets its hands on one single crucial element, oxygen.
And that brings us to the two fundamental categories of exercise. Now, the names might sound a little bit technical, but I promise the ideas behind them are super simple. It's basically with oxygen versus without oxygen. So, on one side, you've got aerobic exercise. This is all your long-distance stuff, jogging, swimming for laps, a long bike ride. It's low to moderate intensity, which means your breathing can easily keep up and deliver all the oxygen your muscles need to completely burn through fuel for energy. But then, on the other side, you have anaerobic exercise. Think all-out sprints, heavy weightlifting, those short, super intense bursts of effort. Your body's working so hard and so fast, it just can't get oxygen to the muscles quick enough. So it has to figure out a way to create energy without it. And that difference is absolutely everything.
Okay, so to really understand how our body makes energy, either with or without oxygen, we have to meet the actual molecule that powers every single twitch, step, and jump. It is the universal energy currency for all life on Earth.
So meet adenosine triphosphate, or just ATP. The absolute easiest way to think about ATP is like a tiny, fully charged battery inside every single one of your cells. When a muscle needs to contract, it just breaks an ATP molecule in half, and boom, you get this little burst of energy. This is the only, and I mean only, fuel source your muscles can use directly. There's just one tiny problem. Your muscles only store enough of these little ATP batteries for about 2 to 3 seconds of all-out work. That's it. So for you to do anything longer than a couple of seconds, your body has to work like crazy to constantly rebuild and recharge those ATP molecules every single second. And how it does that, well, that's where our energy engines come into play. To solve this constant energy crisis, your body doesn't have just one solution. It has three distinct systems, three engines, ready to go at a moment's notice to rapidly pump out more ATP. Two of them are anaerobic. Remember, they don't need oxygen. And one is aerobic. First step is the most explosive engine of them all. This is your immediate get-up-and-go system, your rocket fuel for short, powerful bursts. This is the ATP phosphocreatine system. It's anaerobic, so it doesn't need any oxygen, and it is unbelievably powerful. The second you start an all-out sprint or try to lift a super heavy weight, another substance in your muscles called phosphocreatine basically sacrifices itself to instantly rebuild ATP. But here's the catch. You've only got enough of it for about 8 to 10 seconds of that maximal effort. The really cool thing, though, it's a totally clean burn. It produces no nasty byproducts that make you tired, like lactic acid. So what happens after those first 10 seconds of going all out? Well, your first engine starts to sputter, and that's when engine number 2 kicks into high gear. This is the lactic acid system, sometimes called anaerobic glycolysis. It also works without oxygen, and it takes over for those high-intensity efforts that last longer than 10 seconds. Think of a 400-meter race or a tough HIIT workout. It rapidly breaks down sugar stored in your muscles to generate ATP. But this speed comes at a price, and it creates a very famous byproduct that I guarantee you have felt before. You know that burning sensation you get deep in your muscles during really intense exercise? Yep, that's the buildup of lactic acid, and it's the big limiting factor of this energy system. Eventually, that burn just gets too intense, your muscles start to fatigue, and you're basically forced to slow down or stop altogether. So when the intensity has to drop, or after a couple of minutes when those anaerobic systems just can't keep up the pace, our third and final engine takes over as the main provider. This is the true endurance engine. The aerobic system is your long-haul powerhouse. It uses oxygen, that's the key, to break down sugars and fats to produce a massive, massive amount of ATP. Now, it's a bit slower to get going. It takes a minute or two to really become the dominant system. But once it's up and running, it can sustain you for hours. And its byproducts? Totally harmless. Just carbon dioxide, which you breathe out, and water. This is the engine that powers a marathon runner or a long-distance swimmer.
This table just summarizes everything perfectly. Let's just run through it real quick. The ATP system is for maximal intensity, but it's gone in 10 seconds. The lactic acid system handles high intensity for up to 2 minutes. And the aerobic system? It takes over for all the low to moderate stuff that lasts longer than 2 minutes. See? The intensity and the duration of whatever you're doing is what tells your body which engine needs to be the main one running.
Now, it's really easy to think of these systems as just turning on and off, one by one. But that's not quite right. The reality is actually much more dynamic, much cooler. It's less like a series of light switches and way more like a relay race, where all the runners are actually on the track at the same time.
And this slide right here is fantastic because it shows what scientists call the energy continuum. Just look at the graph. From the very first second of exercise, all three systems are actually chipping in. That dark blue line, the instant ATP, gone in a flash. The light blue line, our sprinter system, peaks and then fades out within 10 seconds. And right as it's fading, look at the green lactic acid system swelling up to take its place before it too starts to decline. All the while that dark green line, our aerobic system, is just slowly and steadily climbing, getting ready to take over for the long haul. One system is always dominant, sure, but they are always working together.
And this is exactly what's happening in most of the sports we love to watch and play. Think about a game of hockey or tennis. You've got these short, maximal sprints to the puck or the ball. That's your ATP system firing on all cylinders. Then you have these high-intensity rallies or shifts that last maybe 30-40 seconds. Hello, lactic acid system. And then you have all the lower-intensity jogging and coasting in between plays, and that's the aerobic system helping you recover so you can get ready for the next burst. It's this constant, beautiful dance between all three engines.
So, whether your goal is to get a little faster in your sprints, last a little longer in a high-intensity class, or maybe even run your first marathon, understanding these energy systems is your secret weapon. They explain exactly why you feel the way you do during exercise, and they show you how to train smarter to get better. So the only question left is, which of your engines are you going to train next?